Hello there, and welcome to the Dreamy Science Channel. I'm so glad you found your way here tonight. Wherever you are in the world, whatever kind of day you've had, this moment is yours. Let the noise of the day soften. Let your shoulders drop. Let your breathing slow down just a little, and allow your thoughts to drift gently upward, toward the sky, toward the stars, toward the ancient light still traveling toward you right now from the far edges of the universe. Tonight's journey is a quiet one. We are going to explore one of the most beautiful and humbling ideas in all of science, the fact that light takes time to travel. And because it does, every time you look up at the night sky, you're not seeing the universe as it is, you're seeing it as it was. Some of that light left its source thousands of years ago, some left millions of years ago, and some began its journey before our solar system even existed. You are, in the most literal sense, a time traveler every time you look at the stars. If these gentle journeys bring you peace, please consider liking and subscribing. It helps others find their way here too. But for now, there is nothing you need to do but rest. Let your body grow heavy, let your eyes grow soft, and let's begin this slow and soothing journey through the ancient light still crossing the universe toward us. Let's begin. Right now, at this very moment, light is arriving at your eyes that began its journey long before you took your first breath. The stars you can see on a clear night are not nearby. They are spread across distances so vast that their light takes years, decades, even centuries to reach us. The closest star beyond our sun, Proxima Centauri, is about 4.2 light years away. That means the light reaching your eyes from that star tonight left its surface more than 4 years ago. You are not seeing that star as it is tonight. You are seeing it as it was 4 years in the past. And for more distant stars, the delay grows tens of years, hundreds of years, thousands of years. Every glance upward is a journey into the past. The night sky is not a window to the present. It is an archive of moments already gone, still arriving. That is fast enough to circle the entire Earth more than 7 times in a single second. Yet, even at this extraordinary speed, the universe is so vast that light still takes enormous amounts of time to cross it. The sun's light takes about 8 minutes to reach Earth. Light from the outer planets takes hours. Light from the nearest star beyond our sun takes years. Nothing in known universe can travel faster than light. This is not simply a practical limit. It is written into the deepest laws of physics. And because of this cosmic speed limit, the universe has a built-in time delay. Every object we observe in its past. The farther away something is, the deeper into history we are seeing. Light is both the messenger and the record, and it always arrives a little late. The warmth you feel from the sun on a bright afternoon is not the sun as it exists right now. It is the sun as it was 8 minutes ago. The light left the sun's surface, crossed 150 million kilometers of empty space, and arrived at Earth, all in just over 8 minutes. By the time it touches your skin, that moment on the sun is already history. But here is something even more remarkable. The light that left the sun's surface 8 minutes ago began its journey much earlier inside the sun itself. Deep in the sun's core, energy is generated by nuclear fusion. That energy works its way outward through layer after layer of dense plasma, bouncing and scattering for an extraordinary length of time. Some estimates suggest hundreds of thousands of years, before finally escaping from the surface. So in a very real sense, the sunlight warming your face today began its journey long before human civilization existed. The moon is our closest neighbor in space, and yet even it shows us a slightly delayed image of itself. Light from the moon takes about 1.3 seconds to reach Earth. That means when you look at the full moon rising over the horizon, you're seeing it as it was just over a second in the past. This delay is so small, it feels meaningless in everyday life, but it is real, and it is a reminder that even the objects closest to us exist at a slight remove in time. Astronauts who walked on the moon during the Apollo missions experienced this delay in communication. When they spoke to mission control on Earth, their words took 1.3 seconds to travel across space, and responses took another 1.3 seconds to return. I have no link that must ever be free. I have no link. A simple conversation had a built-in pause written by the speed of light and the distance between worlds. Proxima Centauri is the closest known star to our solar system, sitting about 4.2 light-years away. The light arriving from it tonight has been traveling for more than 4 years. During those 4 years, you have lived through seasons, experiences, and changes. And all the while, that ancient light was crossing the void between stars, carrying an image of Proxima Centauri as it appeared when it departed. What has happened on Proxima Centauri in those 4 years? We cannot know yet. If something dramatic occurred there tonight, a flare, a change, an event, we would not learn of it for another 4 years. We are always receiving old news from the stars. The universe communicates only as fast as light allows, and light, though breathtaking in its speed, is never quite fast enough to make the cosmos feel close. Stars you can see tonight. May no longer exist. Some of the stars visible in the night sky with the naked eye are hundreds or even thousands of light years away. Stars you can see. The light reaching your eyes tonight from a star 1,000 light years distant left that star 1,000 years ago, when human civilization was in the middle of the medieval period. Whether that star still exists in its current form is something we cannot know. It may have already changed dramatically. In rare cases, a distant star may have already exploded as a supernova. And yet, its ancient light still arrives, steady and calm, carrying no message of its own end. This is one of the most haunting and beautiful ideas in astronomy. The night sky may contain stars that are already gone, stars whose deaths have not yet reached us, whose final moments are still traveling toward Earth, years or centuries away from our detection. We look up and see a sky that is partly a graveyard of light, though we cannot know which points are still shining and which are echoes of something already past. Sirius, the brightest star in the night sky, shows us its past self. Sirius is the brightest star visible from most of Earth, a brilliant blue-white point in the winter sky of the northern hemisphere. It sits about 8.6 light-years from Earth. That means the light arriving from Sirius tonight began its journey 8.6 years ago. When that light left Sirius, it was already on its way before you may have finished a certain school year, before certain world events occurred, before certain things in your own life had yet begun. Ancient Egyptians watched Sirius rise before the sun each year as a sign of the Nile flood season. They named it and revered it. The light they saw was also ancient, a slightly different moment in Sirius's history than the one we observe tonight. Every generation that has ever looked at Sirius has seen a different slice of its past, all of them equally real, all of them equally gone. The light from the Andromeda Galaxy left before humans existed. On a very dark, clear night, you can see the Andromeda Galaxy with the naked eye. It appears as a faint, smudged patch of light near the constellation Perseus. What you are seeing when you look at it is not a star, it is an entire galaxy of over 1 trillion stars, all compressed into that soft glow. And the light reaching your eyes from that galaxy tonight has been traveling for approximately 2.5 million years. When that light began its journey, our ancestors, early humans walking the African savanna, had not yet discovered fire, had not yet developed language, had not yet begun the long story of human civilization. The light crossed the void between galaxies, passed through the darkness of intergalactic space, and arrived tonight at your eyes. It is one of the oldest things you will ever directly perceive. And it costs nothing but a dark sky and a moment of stillness to receive it. In the last 5 minutes of this city, the light can rise and rise. When astronomers point their telescopes at distant galaxies, they are not just seeing faraway places. They are seeing the universe as it was at different stages of its history. A galaxy 500 million light-years away shows us how galaxies looked 500 million years ago. A galaxy 9 billion light-years away shows us the universe when it was only about 9 billion years old. And the most distant objects we can detect, galaxies visible only with the most powerful space telescopes, show us the universe as it was just a few 100 million years after the Big Bang. This layered view of cosmic history is one of astronomy's greatest gifts. The universe has kept its own records, written in light. Every photon traveling toward us is a piece of evidence about the past. By gathering and studying that ancient light, astronomers can reconstruct the history of stars, galaxies, and the expanding cosmos itself. A history written not in stone or ink, but in electromagnetic waves crossing the void. 150 years of cosmic microwave background is the oldest light in the universe. There is a form of ancient light so old that it fills the entire observable universe equally in every direction. It is called the cosmic microwave background, and it is the afterglow of the Big Bang itself. It was produced approximately 380,000 years after the universe began, when the cosmos cooled enough for atoms to form and light to travel freely for the first time. Before that moment, the universe was so hot and dense that light could not move freely. It was constantly scattered by the energetic particles around it. But when atoms formed, the fog cleared and light streamed outward in all directions. That light has been traveling ever since. It has been stretched by the expansion of the universe into microwave radiation, no longer visible to our eyes. But with sensitive instruments, we can detect it as a faint, uniform glow coming from every direction in the sky. It is the oldest light we can observe, a relic from the dawn of the universe, still traveling after nearly 14 billion years. Next, Hannah-Olds Mater T Nassus. The James Webb Space Telescope sees light from the universe's first stars. The James Webb Space Telescope, launched in late 2021 and operating since 2022, was designed to see farther into space, and therefore farther back in time, than any telescope before it. One of its primary missions is to detect the light from the very first stars and galaxies that formed after the Big Bang. These objects are so far away that their light has been traveling for over 13 billion years to reach us. When that ancient light finally arrives at Webb's mirror, it has been stretched by the expansion of the universe from visible light into infrared wavelengths. Light our eyes cannot see, but that Webb's instruments can detect. Every image Webb captures of the early universe is a record of ancient light, completing an almost unimaginable journey. The telescope is not just looking at distant objects. It is receiving messages that were sent before our solar system existed, before Earth was born, before the sun ignited its first nuclear reaction. Light from the sun's core takes hundreds of thousands of years to escape. We know that sunlight takes about 8 minutes to travel from the sun's surface to Earth. But the journey of that light began much, much earlier, deep inside the sun's core, where nuclear fusion generates energy. The core is so incredibly dense that a photon of light cannot travel in a straight line. It is constantly absorbed and re-emitted, scattered in random directions through the dense plasma, in a slow, wandering journey toward the surface. The exact time this takes is difficult to calculate precisely, but estimates range from tens of thousands to hundreds of thousands of years. Some models suggest it could take even longer. By the time that energy finally escapes the sun's surface and begins its 8-minute sprint to Earth, the nuclear reaction that originally produced it may have occurred before the earliest human ancestors walked the Earth. The sunlight of today is ancient energy, finally set free. The telescope does not show us what is, it shows us what was. A small backyard telescope looking at a star cluster hundreds of light years away is receiving light from centuries ago. A large professional telescope studying a distant quasar is receiving light from billions of years in the past. In this way, every telescope ever built is a time machine, not one that can send us backward through time, but one that brings the past forward to us. The universe has been recording its own history in light since the very beginning, and telescopes are the instruments we use to read that record. The deeper we look, the farther back we see. The universe keeps its own archive, and we are slowly learning how to read it. The light arriving from distant quasars left before Earth was born. Quasars are among the most luminous objects in the universe, the brilliantly bright cores of distant galaxies powered by supermassive black holes consuming enormous amounts of matter. Some quasars are so far away that their light has been traveling for over 12 billion years. The light arriving from those distant quasars tonight left its source before our solar system formed, before Earth existed, before the sun ignited its first nuclear reaction. In a sense, quasars are postcards from the early universe. They show us a time when galaxies were younger, more active, and more chaotic, a period astronomers call cosmic noon, when the universe was busiest with star formation and black hole growth. By studying quasar light, astronomers can learn about the conditions of the early cosmos, the distribution of matter between galaxies, and the history of the universe's expansion. Ancient light, arriving at last, tells stories that span billions of years. One of the most remarkable discoveries of modern astronomy is that light does not always travel in a straight line. According to Einstein's theory of general relativity, massive objects bend the fabric of space-time, and light follows that curved path. When light from a distant galaxy passes near a massive object, another galaxy, a cluster of galaxies, or even a large concentration of dark matter, it can be bent and redirected. This phenomenon, called gravitational lensing, means that ancient light can arrive at our telescopes from unexpected directions. In some cases, the same distant galaxy may appear multiple times in our images, its light having taken different curved paths around a foreground mass. In other cases, the lensing magnifies the background object, allowing us to see galaxies that would otherwise be too faint to detect. Ancient light, bent by gravity on its long journey, becomes a tool for exploring the invisible structure of the universe. Here is one of the most astonishing consequences of the expanding universe. Some of the light arriving at our telescopes tonight came from galaxies that are now so far away that they are receding from us faster than light can travel. That seems impossible, yet it is a real consequence of how space itself expands. The galaxies are not moving through space faster than light, rather, the space between us and them is stretching so rapidly that the effective distance is drawing faster than light can cross it. This means that the light we are receiving now from those distant galaxies was emitted when they were much closer to us. Since then, both the light and the galaxy have been moving, the light toward us and the galaxy away. The light eventually reached us, but the galaxy itself is now forever beyond our ability to communicate with, observe further, or ever reach. Ancient light is sometimes the last message we will ever receive from a place that has since become permanently unreachable. In 1995, astronomers pointed the Hubble Space Telescope at a tiny patch of sky that appeared completely empty to ordinary observation. A region no wider than a small grain of sand, held at arm's length. They let the telescope collect light for 10 consecutive days. When the image was processed, it revealed thousands of galaxies packed into that tiny slice of sky, each one a collection of billions of stars. Each one at a different distance, and therefore showing us a different moment in the universe's past. The Hubble Deep Field became one of the most famous images in the history of science. It showed, in a single picture, that the universe is not empty. It is saturated with galaxies, with light, with history. Every one of those thousands of galaxies sent its ancient light on a journey of millions or billions of years, all converging on Hubble's mirror during those 10 days of patient watching. The image is not a snapshot of the universe as it is. It is a layered archive of the universe across time. 160 light from supernovae has carried news of stellar deaths across the galaxy. When a massive star exhausts its fuel and explodes as a supernova, it briefly outshines an entire galaxy. The light from that explosion travels outward in all directions at the speed of light, carrying news of the star's death across the cosmos. In 1987, astronomers detected light from a supernova in the Large Magellanic Cloud, a small galaxy neighboring the Milky Way, about 168,000 light-years away. That means the explosion actually occurred 168,000 years before we witnessed it. The light of that stellar death crossed the void for longer than our entire species has existed, before finally arriving at Earth. Just before the light arrived, something else arrived first, a burst of neutrinos, ghostly particles produced in the collapsing core of the dying star. These neutrinos travel at nearly the speed of light and pass through almost everything, including Earth. They were detected by underground detectors just hours before the light of the explosion reached our telescopes. Ancient messengers of a stellar catastrophe, arriving after a journey of 168,000 years. It contains thin clouds of gas, mostly hydrogen, spread across the vast voids of intergalactic space. When ancient light from a distant quasar or galaxy passes through these clouds, some wavelengths are absorbed. By studying which wavelengths are missing from the light, astronomers can learn about the composition, temperature, and distribution of gas along the entire line of sight between us and the distant source. This technique has allowed astronomers to map the cosmic web, the large-scale structure of filaments and voids that gives the universe its form. Ancient light, carrying the fingerprints of every gas cloud it passed through on its billions of years journey, becomes a probe of the invisible structure of the cosmos. The light arrives changed, marked by its encounters with the universe, and those marks tell the story of everything it passed through on the way. The center of our own galaxy, the Milky Way, is about 26,000 light-years from Earth. The light arriving from the galactic center tonight has been traveling for 26,000 years. When it began its journey, the last ice age was still underway on Earth. Woolly mammoths still roamed the northern continents. The earliest cave paintings were being made by our ancestors. Human civilization as we know it, agriculture, cities, writing, had not yet begun. That ancient light crossed the dense, dusty heart of the galaxy, navigated the spiral arms, and traveled through thousands of light-years of interstellar space before finally arriving at our instruments. Much of it is blocked by dust and cannot be seen in visible light, but in infrared and radio wavelengths, we can receive signals from the galactic center, ancient messages from the heart of our own cosmic home. Sent before recorded human history began. Some ancient light has been stretched into invisibility by the expanding universe. When light travels across an expanding universe, something remarkable happens to it. As the space between the source and the observer expands, the wavelength of the light is stretched. This stretching is called redshift because the light shifts toward the red end of the spectrum and beyond. For the most distant objects in the universe, the light has been stretched so dramatically that it is no longer visible light at all. It has been stretched into infrared radiation or even into microwaves. This is why the cosmic microwave background, the afterglow of the Big Bang, is no longer visible to human eyes. When it was emitted, 380,000 years after the Big Bang, it was hot, energetic light. But 13.8 billion years of cosmic expansion have stretched it into microwave radiation. The light is still ancient, still traveling, still arriving, but transformed by its long journey through an expanding cosmos into something our eyes cannot perceive without instruments. The light from the most distant galaxies shows the universe in its infancy. The most distant galaxies detected by modern telescopes are so far away that their light has been traveling for over 13 billion years. When that light was emitted, the universe was less than 1 billion years old, a cosmic infant, still forming its first stars and galaxies. The galaxies visible at those extreme distances look nothing like the mature, ordered spirals and ellipticals we see nearby. They are smaller, more irregular, more chaotic, still assembling themselves from the raw material of the early universe. By studying the light from these ancient galaxies, astronomers can watch the universe grow up. They can see how galaxies formed, merged, and changed over billions of years. They can trace the history of star formation, the spread of heavy elements, and the slow organization of matter into the cosmic structures we see today. Ancient light, arriving from the edge of the observable universe, carries the story of everything that came before. Light from a star can arrive long after the star has gone cold. White dwarfs are the slowly cooling remnants of stars like our Sun. After a star exhausts its fuel and sheds its outer layers, the remaining core, a white dwarf, begins a long, slow cooling process that takes billions, even trillions of years. The light we receive from a white dwarf is the fading glow of a stellar ember, not the fire of an active star, but the lingering warmth of something that burned out long ago. In a sense, all the light we receive from white dwarfs is ancient in a double way. It is old because of the distance it has traveled to reach us, and it comes from a source that is itself the remnant of a much older story, the long life and quiet death of a star that lived and burned and faded before its light ever reached our eyes. The universe is full of such echoes, light from sources that have already changed beyond recognition, still traveling, still arriving, carrying images of a past that no longer exists. Light waves and time are inseparable. Across the cosmos, one of the deepest insights of modern physics is that space and time are not separate things. They are woven together into a single fabric called space-time. And light, traveling at the maximum speed the universe allows, connects points in that fabric in a unique way. When we observe ancient light, we are not just looking across space, we are looking across time. The two are inseparable. Every photon of light arriving at our eyes or our instruments carries a timestamp, the moment it was emitted. And the journey it has made is not just a journey through space, it is a journey through time. The universe uses light to communicate across its vast distances, and because light takes time to travel, every communication arrives from the past. We live in a universe where the present is always surrounded by messages from history arriving continuously from every direction at the speed of light. Some of the oldest light carries clues about the first elements. The cosmic microwave background, that ancient afterglow of the Big Bang, is not perfectly uniform. It contains tiny variations in temperature and density, patterns imprinted on the light when the universe was only 380,000 years old. These patterns encode information about the composition of the early universe, the relative amounts of ordinary matter, dark matter, and dark energy, and the seeds of the large-scale structure we see today. By studying these ancient patterns in ancient light, cosmologists have been able to determine the age of the universe with remarkable precision, measure the geometry of space, and learn about the first elements that formed in the minutes after the Big Bang. Ancient light is not just beautiful, it is one of the most information-rich messengers in all of science. Every photon of the cosmic microwave background that reaches our instruments carries a record of the universe's earliest moments. On its long journey from a distant star to your eyes, starlight does not always travel through empty space. It passes through clouds of gas and dust, the nebulae that drift between the stars. These clouds can absorb, scatter, and change the color of the light passing through them. Blue light is scattered more easily than red, which is why distant stars often appear redder than they truly are. Their blue light has been scattered away during the journey. But sometimes the interaction between starlight and nebulae creates something beautiful. The light can illuminate the clouds themselves, causing them to glow with reflected or re-emitted light. Reflection nebulae glow with the blue light scattered from nearby stars. Emission nebulae glow with their own light, energized by the ultraviolet radiation of hot, young stars. In both cases, the ancient light of stars is transformed by its encounter with the material between us, arriving changed, but still carrying its original message. The light we see from distant galaxies left before our sun was born. Our sun is approximately 4.6 billion years old, but many of the galaxies visible in deep sky images are so far away that their light left them long before our sun existed. A galaxy 6 billion light-years away shows us what it looked like 6 billion years ago, before Earth was formed, before our solar system had begun to condense from a cloud of gas and dust, before any of the atoms in your body had been assembled into the forms they now occupy. The light crossed billions of light-years of expanding space while our solar system formed, while life evolved on Earth, while civilizations rose and fell, while you grew from a child into whoever you are tonight. And now it arrives, ancient beyond comprehension, carrying an image of a universe that existed before our world did. That light has been patient in a way nothing else can be. It simply traveled, crossing time, until it found you. Anti-Richu owns ancient light. Ancient light has helped us measure the expansion of the universe. In the early 20th century, astronomers noticed something surprising in the light from distant galaxies. The light was redshifted, its wavelengths stretched toward the red end of the spectrum. And the farther away a galaxy was, more redshifted its light appeared. This discovery, confirmed and refined over decades, revealed that the universe is expanding. Every galaxy is moving away from every other galaxy, carried apart by the expansion of space itself. By studying how ancient light from distant supernovae and galaxies is redshifted, astronomers have been able to measure not just that the universe is expanding, but how fast it is expanding, and how that rate has changed over billions of years. In a stunning discovery in the 1990s, this ancient light revealed that the expansion of the universe is not slowing down as expected, but accelerating. Something, which we call dark energy, is pushing the universe apart at an ever-increasing rate. Ancient light carried the evidence of this discovery to us, written in the stretching of its own wavelengths. When you look at the night sky, you are not seeing a single moment. You are seeing many moments, layered together, a mosaic of different eras in the universe's history, all arriving simultaneously at your eyes. The moon shows you 1.3 seconds ago. The sun shows you 8 minutes ago, Nearby stars show you years or decades into the past. The Milky Way's own structure shows you thousands. The mountain shows you millions or billions of years back. All of these different slices of history arrive together, overlapping in a single field of view. The night sky is a time machine with no single destination. It shows you many different pasts simultaneously. And every night you look up, you are receiving a fresh delivery of ancient light. Messages from the universe's own history arriving right on schedule, as they have for as long as there have been eyes to receive them. Some ancient light will never reach us. There are regions of the universe from which no light will ever reach us. Not because the light is blocked, but because the universe is expanding so fast that the light from those distant regions can never cross the growing gulf of space between us and them. These regions lie beyond what astronomers call the cosmological event horizon, the boundary beyond which communication with us is forever impossible. This means the observable universe is only a portion of the full universe. Beyond the edge of what we can see, reality continues, but its light will never arrive. Ancient light from beyond that horizon has been traveling toward us since the beginning of the universe, yet the expanding space has always kept it just out of reach. In a universe that is growing, some messages are lost in transit forever. The light is real, the sources are real, but some ancient light will travel for eternity without ever finding an eye to receive it. Anthony Grab T. Bells has crab tea.
When light passes through a gas, whether the atmosphere of a star, a nebula, or a cloud of interstellar hydrogen, certain wavelengths are absorbed. Each element absorbs specific wavelengths, leaving dark lines in the spectrum of the light, a kind of fingerprint unique to each atom. By analyzing the spectrum of ancient light from distant stars and galaxies, astronomers can determine exactly which elements are present in those distant objects and in everything the light passed through on its journey. This technique, called spectroscopy, has allowed astronomers to discover that the same elements found on Earth are present throughout the universe. Hydrogen, helium, carbon, oxygen, iron, the building blocks of life, are scattered across every galaxy we can observe. Ancient light, carrying these chemical fingerprints across billions of light years, has told us that the universe is made of the same stuff everywhere. We are not chemically unique.
The atoms in your body are the same kinds of atoms that fill the most distant galaxies whose light is arriving tonight. The universe may contain light we can never observe beyond the observable universe, the sphere of space from which light has had time to reach us since the Big Bang. There may be an unimaginably vast universe that we will never see. If the universe is infinite, or even if it is merely much larger than the observable portion, then there are regions whose light has never reached us and never will. The light from those regions has been traveling since the beginning of time and has not yet crossed the distance to us. This is not because the universe has a wall or an edge. It simply means there is a limit to how far light can travel in the time the universe has existed. That limit defines our cosmic horizon, the boundary of our observable universe. Beyond it, the universe is almost certainly real and filled with matter, energy, and structure, but forever beyond our sight, hidden not by walls, but by time and distance. Ancient light is both our greatest gift and our greatest limitation. It tells us everything we know about the cosmos, but also defines everything we can never see. Light arriving tonight has crossed the void between galaxy clusters. The largest structures in the observable universe are galaxy clusters and superclusters, vast groupings of hundreds or thousands of galaxies bound together by gravity. Between these clusters lie the great cosmic voids, enormous regions of space nearly empty of galaxies, stretching for hundreds of millions of light years. Ancient light from distant galaxies has crossed these voids on its journey toward us, traveling through some of the emptiest regions of the universe. In those voids, a photon of light can travel for hundreds of millions of years without encountering a single star, a single planet, or a single atom of gas. The silence of those passages is absolute. The light travels on, unchanged, through an emptiness that makes even the space between stars seem crowded. And then it arrives at our galaxy, our solar system, our atmosphere, our eyes, completing a journey through some of the most desolate regions in existence, carrying its ancient message intact. Ancient starlight has been guiding humans since the beginning. Long before telescopes, long before the science of astronomy, human beings looked up at a night sky and used the light of distant stars to find their way. Sailors navigated by the stars, following light that had traveled for years or centuries across the void. Farmers tracked the positions of stars to know when to plant and harvest. Ancient monuments were built to align with specific stellar events. The patterns of starlight guided the first migrations of humanity across continents and oceans. All of these navigators, farmers, and builders were using ancient light without knowing it. The light that guided a Polynesian navigator across the Pacific had left its star centuries before that navigator was born. The light that aligned Stonehenge with the summer solstice was already ancient when those stones were raised. Ancient light has been humanity's oldest and most reliable guide, a connection between the present and the deep past of the cosmos, woven into the story of our species from the very beginning. Every photon is a survivor of an unimaginable journey. Consider what a single photon of light must endure on its journey from a distant star to your eye. It is created in a nuclear reaction in the heart of a star, works its way slowly through layers of dense plasma, escapes into the void of space, travels for years or centuries or billions of years through the expanding universe, passes perhaps through nebulae and gas clouds, dodges the gravity of intervening masses, crosses the last 150 million kilometers to Earth in just over 8 minutes, penetrates Earth's atmosphere without being absorbed, and finally arrives at your retina, where it is converted into an electrical signal and becomes, somehow, the experience of light. Every star you see is the result of this improbable survival. Most photons are absorbed along the way, scattered, redirected, lost. The ones that reach you are the survivors, ancient travelers that completed an extraordinary journey just to land in your eye in this particular moment. The night sky is full of survivors carrying ancient messages, and you tonight are their destination. The cosmic microwave background, the oldest light in the universe, is not a historical artifact locked away somewhere. It is arriving right now, at this very moment, from every direction in the sky. Your body is bathed in it constantly. Every square centimeter of space around you is crossed by photons of ancient microwave radiation, relics of the universe's first light, still traveling after merely 14 billion years. This ancient light cannot be seen, but it can be measured. The instruments that detect it are receiving the universe's own autobiography, a record of its earliest moments, preserved in the form of electromagnetic radiation that has been traveling since before stars existed, before galaxies formed, before any of the complexity we see in the universe today had come into being. Ancient light is not just a feature of the night sky. It fills the universe entirely, in every direction, at every moment, carrying the oldest story ever told. 100 Unhulls Rabbit Crew. Closing, and so we come gently to the end of tonight's journey. A journey not through space alone, but through time. through light that has traveled for moments and light that has traveled for billions of years, all of it arriving, all of it carrying its message, all of it weaving together into the night sky above you. The light touching your world right now is ancient. Some of it is older than our planet, some of it is older than our solar system. Some of it has been traveling since before the first stars lit the darkness of the early universe. And all of it, after its long and extraordinary journey, has found you, here, tonight, in this quiet moment. You are the destination of ancient light. You are the receiver of the universe's oldest messages. Every time you look up at the stars, you are participating in a connection that stretches across billions of years and billions of light years. A connection between the cosmos and the small, wondering creatures who learn to look up and ask what all that light means. So now, let your thoughts drift softly among the stars. Let the ancient light settle gently in your mind like starlight on still water. Let your breathing slow. Let your body grow heavy. Let the great distances of space and time become something peaceful, a reminder of how vast and patient the universe is, and how quietly it has been sending its light toward you all along. If this journey brought you peace, please consider liking, subscribing, or leaving a quiet thought below. It helps others find their way here too. But for now, there is nothing left to do. The ancient light is still traveling. The stars are still shining, and you can simply rest, knowing that somewhere out there, light is crossing the universe right now, patient and unhurried, making its way toward you. Sleep well, and good night.